Welcome to Yatimkhana and Madrasa Anjuman Khairul Islam's Pune College of Art, Science and Commerce. Myself, Dr. Arif Tamboli, working as Associate Professor in the Department of Electronic Science. Today we are going to study the formation of depletion region, which is also called as depletion layer, barrier potential and junction capacitor in PN junction diode. So today's lecture is very important lecture because when we combine a p-type material to the n-type material, at that time what happens exactly at the junction? So these three things are very important. That is, at the junction, the formation of depletion region takes place, the formation of barrier potential takes place, and formation of junction capacitor also takes place inside PN junction diode. So let us start because already we have covered everything about p-type material and n-type material, which is extrinsic semiconductor material. Now, as shown below, when p-type semiconductor, a semiconductor material, is combined with n-type semiconductor material as a single crystal, of course, at that time, the free electrons of n-type material starts migrating towards the holes on p side. So now let us go to the diagram and understand that. Now see here in this diagram very carefully. On right hand side there is n-type material, and all of you are aware that now n-type material is fabricated such that a single atom in this diagram, a single atom of pentavalent impurity, which is called phosphorus here. Here this P stands for phosphorus and it is a pentavalent impurity atom. When pentavalent impurity single atom is added, it creates one free electron. Why? Because this pentavalent impurity is having valency phi and 4 electrons are shared with the 4 silicon atom, which are very neighbor to this, and one excess electron is called free electron. So this is about n-type material which you already studied. Let us come to the left hand side, that is a p-type material. In p-type material, all of you know that aluminum is a what? Trivalent impurity. Aluminum is a trivalent impurity and 3 valence electrons of aluminum atom are shared with 3 silicon atoms, and this aluminum atom does not have a fourth electron to share with this fourth silicon atom, and that non having a fourth electron is called as hole, So in this way now, let us consider that this p-type material and this n-type material, normally p-type material is on left hand side, n-type material is on right hand side, which we consider. When we combine this material of p-type material to the n-type material, what happens? This structure is having one free electron and this structure is having one less electron. So this structure is having less electron means there is a vacancy of electron, and that we called as a hole. And there is a free electron means excess electron of this pentavalent impurity. And now what happens when you combine p-type material to n-type material, this excess electron, that is a free electron, will jump into the hole on left hand side, and then what will happen? Formation of PN junction formation of PN junction takes place, and in this case here, now after jumping the electron from right hand side to left hand side, this structure which was having excess electron becomes stable, and this structure also becomes stable because it was having a shortage of electron, and this structure gain the electron, this structure loses the electron. And in this way here, this is a very simple diagram I have shown. How does the migration of electron will take place? Because there is a vacancy of electron, that is the hole, and here there is excess electron, one electron is extra. So this, when you combine to this electron will jump into this hole, and that is what here it is given. Due to migration of electron, now this electron will migrate from right hand side to left hand side and jump into the hole. So due to the migration of electron, the total negative charge of aluminum, now when this electron migrates from this side to this side, the total negative charge of aluminum atom will increase because it was already having three electrons, and now there is one more electron which is what occupying into this hole. Therefore total negative charge, because electron is a negative charge particle, therefore total negative charge of this aluminum atom will increase. And what will happen about this phosphorus atom, atom of pentavalent impurity? That pentavalent impurity atom loses the electron, therefore its negative charge is decreased. Its negative charge is decreased, and that is, in another language, it is called as, when negative charge is decreased, it is said that it is going towards positive charge. It is going towards positive charge, and that is what here in the diagram I'll show you. Due to migration of electron, the total negative charge of aluminum, that is trivalent atom on left hand side, increases, and total negative charge of phosphorus pentavalent atom decreases, because this atom is losing the electron and this atom is gaining the electron. Therefore electron is a negative charge particle, therefore aluminum atom's negative charge will increase. Phosphorus means pentavalent impurity atom's negative charge will decrease. Therefore, the atom of aluminium, that is a trivalent, therefore the atom of aluminium, that is a trivalent impurity, is indicated as atom with negative charge inside the depletion layer on LHS. So I am going to show you that diagram of depletion layer. So inside the depletion layer, the atom on left hand side will be marked as a what? Negative charge, minus sign. Why? Because total negative charge is increased. Therefore, the atom of aluminium, that is trivalent impurity, is indicated as atom with negative charge inside depletion layer on left hand side. So that diagram I'm going to show you in the next slide. Now on RHS, what will happen? On RHS, the decrease in negative charge causes to increase the charge towards positive. On RHS, the decrease in negative charge causes to increase the charge towards positive. Why? Because here you see this electron migrates from right hand side to left hand side. Therefore, total number of electrons present here will be less, and therefore negative charge will decrease. So decrease in the negative charge is called as, on right hand side, it is called as causes to increase the charge towards the positive. Now here see, this diagram will indicate you. Suppose the negative charge is very much negative, means on the left hand side, and this negative charge is decreased. Negative charge is decreased means what? It will come towards zero. It will come towards zero, and therefore it is called as, on RHS, the decrease in negative charge, when negative charge is decreased means it will come towards zero. The decrease in negative charge causes, the decrease in negative charge causes to increase the charge towards the positive, and therefore the atoms on the right hand side will be marked as a positive, and in this way here, the formation of depletion layer, how does it takes place, that we are going to understand. So on the right hand side, decrease in negative charge causes to increase the charge towards the positive. Therefore that atom is indicated, as atom with positive charge inside depletion layer on RHS right hand side. And that diagram I am going to show you in the, because already we have studied in the second lecture that diagram of PN junction. So it is a depletion layers, this thing here. See, here, this is your p-type material, this is n-type material. When we combine p-type material with n-type material, what is happening? The migration of electron, free electron, will jump towards the p-side material. Why it is jumping towards p-side material? Because in p-side material there is a vacancy of electron, and the atom of p-type material is gaining the electron, therefore total negative charge is increased. Therefore see here, inside depletion layer on left hand side, all that atoms, those who have got the electron, their negative charge is increased, therefore it is minus, 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 and minus. Now all those atoms on right hand side, right hand side who have lost the electron, who have lost the electron, their negative charge is decreased, means it is going towards the positive charge, means it is going towards positive charge, and therefore it is marked as plus 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 plus. So in this way, on right hand side, very close to junction, on right hand side very close to the junction, the atoms, those who have lost the electron, their negative charge is decreased, means they are going towards the positive charge, and therefore it is marked as a plus. The atoms on the left hand side of the junction, see, this is the junction, and atoms on the left hand side of the junction, those who have gained the electron, their negative charge is increased, therefore this is marked as a minus. And this is very important when you combine a p-type material with n-type material, and that is what here I have explained you with the help of a single crystal. With the help of a single crystal, means here single atom I have taken into consideration, p-type material and n-type material. So here, so this is a p-type material and n-type material, single atom I have taken, phosphorus one atom and aluminum one atom. So it becomes easy to understand how does this free electron will jump into the hole on left hand side. And here now, therefore, that atom is indicated as atom with positive charge inside the depletion layer on right hand side. An atom, an atom that has lost electron, an atom that has lost electron and has a positive charge is called as cation, is called as cation. So you know that now a pentavalent impurity atom lost the electron, pentavalent impurity atom lost the electron, therefore the atom which is losing the electron, therefore the atom which is losing the electron, lost the electron and has a positive charge, its negative charge is decreased, means going towards the positive charge, is cation, is called as cation, that is called cathode terminal on the right hand side. An atom that has gained electron, that has gained electron and has a negative charge, and has a negative charge, because upon gaining the electron, the total negative charge will increase, because electron is negative charge particle, a negative charge is increased, and that atom is called anion, anion, that is anode terminal on left hand side. And in this way, cathode and anode terminal names are given accordingly. Why the cathode is called cathode? Because on right hand side, pentavalent impurity atom loses the electron, pentavalent impurity atom loses the electron, and when that atom loses the electron, it is called as cation, it is called as cation. And on left hand side, a trivalent impurity atom gain the electron, trivalent impurity atom gain the electron, and that is called anion, and that is called anion, because upon gaining the electron, the total negative charge is increased. And when the total negative charge of that atom is increased upon gaining the electron, it is called anion. Anion are having more negative charge and cation are having more positive charge. So here, after understanding this basic concept, you will come to conclusion that ions are atoms that have lost or gained electrons. Ions are atoms that have lost or gained the electron, and therefore have a net charge, and therefore have a net charge. Now, what do you mean by the net charge? Octet is completed. What do you mean by the net charge? Net charge means octet is completed. So try to understand here. This atom was not stable. Why? Because it was having excess electron. This atom also was not stable because it is having one electron less. So neither this atom is stable nor this atom is stable. But the stability of this atom is disturbed because of it is having excess, and stability of this atom is disturbed because it is having less. Therefore, when this atom is what losing the electron, then it becomes stable and octet is completed. How does octet is completed? 4 electrons from phosphorus atom and 4 electrons are shared with 4th electron, and octet is completed. Upon gaining, aluminum atom will complete octet. How come? 4 electrons of these 3 electrons of aluminum. One is from gaining the electron and 4 shared electron with the silicon. And therefore here, upon migration of the electron from p-type material, so from n-type material to p-type material, these atoms becomes stable. As atom becomes stable, and stability is causing to what? Get the atom converted into ion. So ion are atoms that have lost or gain electron and therefore have a net charge, and therefore have a net charge. Net charge means octet is completed. Means, once again I will repeat, octet is completed means the atom which was having excess is losing, an atom which was having a less electron is gaining, and that atoms are converted into ion. And there are two types of the ion: anion and cation. Anion and cation, and this also we have studied over here. What do you mean by the cation? So here the atom which is losing the electron is called cation, because its total negative charge decrease means positive charge is increase. An atom which is gaining the electron means upon gaining the electron, the total negative charge is increased, and that is called anion. Now here in again a simple language it is explained. Ions. What do you mean by ions? Ions are electrically charged atom. Ions are electrically charged atom. This is very important. So neutral atom. So first of all, before converting the atom into ion, what is a atom? Atom is a neutral. So here, when any neutral atom loses the electron, see on the right hand side, when any neutral atom loses the electron means what? It loses the electron, LOSE, lose the electron, loses the electron means total negative charge will decrease, and that is called increase in the positive charge. So positive charge is increased. Positive charge is greater than the negative charge of the electron. So here P plus is greater than here, and this is called your positive ion, and it is called cation. This is called positive ion because it lost the electron, it loses the electron, and that is called cation. Come on the left hand side. Neutral atom when it gain the electron. Neutral atom when it gain the electron. Upon gaining the electron, the negative charge is increased means total electronic charge. Here E minus is greater than positive charge. Then what? Positive charge. So here it is a positive charge is less and negative charge is more, and that is called anion. That is called anion. So when any neutral atom, so here in this, in our case, so this is your is gaining the electron, so it is called anion. Upon gaining the electron, this will converted into anion, and upon losing the electron, this will converted into cation. So anion and cations, if you understood, then one more diagram here. Neutral atom, when any neutral atom loss of electron, so loss of electron E minus. So here when it loses the electron, it gets converted into cation, because negative charge is decreased means positive charge will increase. And in this way here, that neutral atom when it gains the electron, neutral atom when it gains the electron, gain of electron, then that is called anion. So this diagram is also very self-explanatory. Now this is one funny diagram. So here it is a ion. Okay, so you can see here cation. Cation is angry because it is losing the electron. Anion is happy because it is gaining the electron, and total negative charge of anion is increased, and here negative charge is decreased means going towards the positive charge. So this is just as a fun. Now in reality we are going to study the formation of depletion region, barrier potential, and junction capacitor. So now try to understand. This diagram is again a self-explanatory, and it is a very important. When a p-type material, on the left hand side here, see p-type material. Now here it is given positive green, all these are holes. Positive green, all these are holes. So in p-type material there are majority charge carriers are the holes. And what is a hole? Hole is nothing but the vacancy of electron. Now come on the right hand side, there is an n-type material. N-type material. Now what is this minus minus? This minus minus is nothing but free electrons. It is a negative charge on electron. So n-type material is having large number of free electron and majority charge carriers are electrons. P-type material is having large number of holes and majority charge carriers are holes. Now here, this is a crystal. See here, boundary, black boundary. So when you combine a p-type material to n-type material, what happens? As already I have explained you, and once again we are going to repeat over here. So you will understand here, this is a depletion region. This is a depletion region, and the formation of depletion region, formation of barrier potential, and formation of junction capacitor. Three things happen simultaneously at a time. So when you combine a p-type material with n-type material, what happens? All of you know very well, because here I have already explained you by taking a single atom of pentavalent impurity, a single atom of pentavalent impurity dope into the silicon, means n-type material, combined with a single atom of aluminum impurity, that is a trivalent, dope into the silicon, that is a p-type material. What happens? Migration of electron take place from n-type material, from n-type. Now this is entire is n-type material, this entire is n-type material, and this entire is your p-type material. So migration of electron from inside material will take place towards the p-type material, because here see, this is a free electron, and that is what here we mark that free electron as a minus sign. That is what here we have marked this free electron as a minus sign. So now what will happen here? At the junction, when we combine p-type material with n-type material, exactly at the junction, the atoms on the right hand side, atom on the right hand side, those who are having atom on the right hand side means what? Yes, which atom? Atom on the right hand side means atoms of pentavalent impurity. Atoms of pentavalent impurity, they are having excess electron, and therefore on the right hand side, the atoms, those who are having excess electrons, they will donate the electron, or this electron will jump on the left hand side, because on the left hand side what is there? P-type material. In p-type material there are holes, means atoms of trivalent impurity are having a vacancy of electron. Atom of trivalent impurity is having a vacancy of electron, and therefore here, very close to the junction, look at this vertical line, it is a junction. Very close to the junction on right hand side, the electrons will migrate to the left hand side. Electron will migrate to the left hand side. And why the electrons are migrating? Because there is a vacancy of electron, that is a hole. And when the electron will migrate from right hand side, means n-type material, to left hand side, all atoms on the right hand side, all atoms on the right hand side, those who have lost the electron, those who have lost the electron will converted into, see here, plus plus plus, positive ion, that is called cation, will converted into positive ion, that is called cation, and therefore this terminal on the right hand side is called cathode. This terminal is called, on the right hand side, is called cathode, because here all these atoms are converted into cation. Why they have converted into cation? Because they have lost the electron and their negative charge is decreased, means positive charge is increased, therefore it is marked as plus plus plus. And then on the left hand side you come, all those atoms who have gained the electron, and their, upon gaining the electron, their negative charge is increased, therefore it is called minus minus minus. Why it is a minus? Because total negative charge is increased. And look at this minus minus, this is called anion, that is negative ion. This is called anion, that is a negative ion, because all these atoms are lucky, they have gained the electron, and upon gaining the electron, their negative charge is increased, therefore it is a minus. And look at this here now, this terminal is a minus because here negative charge is increased. This terminal is minus, it is a barrier potential. Now this terminal is a minus because all these atoms negative charge is increased, and this terminal is called plus. So this is very important. Why there is a plus here? Because all these atoms lost the electron, and upon losing the electron, their negative charge is decreased, means positive charge is increased and they have converted into positive ion, and these atoms converted into negative ion. And if you understood this, then here only you have understood that this is the formation of barrier potential. Now question comes here, how long time the electron migration will continue from this side to that side? How long time the migration of electron from right hand side means n type material to left hand side means p type material will continue? So here you will get the answer, when the atoms on left hand side of the junction, when the atoms on the left hand side of the junction means atoms of trivalent impurity gain the electron, atoms of trivalent impurity gain the electron and complete the octet, at that time the total negative charge is increased, and if this negative charge of all atoms very close to the junction on the left hand side is very huge, is very large, then this negative charge will repel the electron which is coming from right hand side to left hand side, because negative charge repels each other, negative charges repels each other, and in this way here that phenomena is called here the migration of electron from right hand side, that is n type material, to left hand side, that is p type material, will continue till equilibrium. Till equilibrium means unless and until here the negative charge does not increases to that level, to that level, after that level it will oppose to the negatively charged electrons migrating from this side to that side, and this is called your formation of depletion layer. Now very important fact is what, inside the depletion layer, inside the depletion layer on the right hand side there is a positive ion, and on the left hand side there is a negative ion. See here, now on the left hand side there is a negative ion and on the right hand side there is a positive ion, but very important fact is what, all the atoms inside the depletion layer have completed its octet, or their octet have completed their octet, and therefore here it is said that inside the depletion layer no charge carrier, inside the depletion layer no charge carrier, because the octet is completed and atoms are converted into respective ions. On the right hand side it is positive ion, that is called cation, and on the left hand side it is negative ion, that is anion. And therefore here there is a statement which I have studied in second lecture, inside the depletion layer there is no charge carrier, there is no charge carrier, these atoms are converted into anion and cation, are converted into anion and cation, and therefore all these atoms behaves as dielectric material. That is again important concept. All these atoms inside depletion layer behaves as dielectric material. So here this diagram is very simple and self-explanatory. So once again I will repeat, p-type material is having large number of holes marked by the positive sign. N-type material is having large number of free electrons marked by the negative sign. When p-type material is combined with n-type material in a single crystal, migration of electron from n-side material will take place towards the p-type material. So the atoms, those who are losing the electron, the atoms on the right hand side of n-type material losing the electron, and upon losing the electron their negative charge is decreased, means positive charge is increased, and therefore at the junction on the right hand side the atoms those who have lost the electron, they are marked by the plus sign, and it is called the positive ion, that is cation, and therefore this terminal is cathode. On the left hand side the atom those who have gained the electron, on the left hand side means p-type material, the atoms those who have gained the electron, their total negative charge is increased, and that atom is converted into anion, and that is a negative ion, and therefore it is called anode terminal. It is called anode terminal. Migration will continue unless and until the total negative charge on the left hand side will increase to that level or to that extent which start opposing for further migration of electrons, and that is called till equilibrium. And in this way here inside the depletion layer there is a what, the atoms are converted into ions, that is negative ion and positive ion, and therefore there is no charge carrier inside depletion layer. because each atom got converted into ion. And this whatever I explain you, all these things we have written in the next slide, and that we are going to study. So here this negative terminal is there and this positive terminal is there, and this is called barrier potential. This is called barrier potential. Electrostatic field, it is what? Electrostatic field. And this is the depletion region. This is the depletion region. Inside depletion region there are anion and cation. Inside the depletion region there are anion and cation. On the left hand side there is anion because there is anode terminal, and on the right hand side there is a cation there because there is a cathode terminal, because PN junction is taken as P type on left hand side, N type on right hand side. And accordingly this diagram, whatever it is given over here in this diagram, four factors are there: minus 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 free electrons, plus 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 holes are there. This minus with circle is the what? Gaining of the electron of that atom. Negative ion, it is anion. Plus with circle, so it is called positive ion, losing the electron. And this is anode, this is cathode. This depletion region is very important, and inside this depletion region all these atoms all these atoms are behaving as dielectric material. Therefore this depletion layer is also called as junction capacitor. Is also called as junction capacitor. On left hand side p-type material act as a one positive one plate, and on the right hand side n-type material act as a one plate, and in between these two plates all these anions and cation in between these two plates of p-type material and n-type material act as a plates, and in between these two plates all these atoms, that is anion and cation, act as dielectric material. And this is what we have explained here. As shown in above diagram, when p-type semiconductor material is combined with n-type semiconductor material, single crystal, at that time free electrons of n-type material starts migrating towards the holes on p side, and of course very close to the junction. So here the migration of electron at the PN junction take place till equilibrium, means when negative charge on left hand side is increased, at that time this negative charge opposes for further migration of electrons due to repulsive force between negative charge, and formation of depletion layer take place due to repulsive force between negative charges. Means electron is a negative charge particle. When negative on the left hand side negative charge is increased, at that time this negative charge opposes for further migration of electrons due to repulsive force between negative charge, and formation of depletion layer takes place. The atoms inside the depletion region, are now converted into ions, because each atom is stable such that octet of each atom on left hand side as well as right hand side very close to junction is completed. Very close to junction is completed means what? Neither having the shortage of electron nor having the excess of electron. Means very close to the junction, the atoms, those who have donated, those who have lost the electron, here on this right hand side, the atoms those who have lost the electron, they are now stable, because already they were having excess electron and therefore they were not stable. So upon losing the electron they become stable. These atoms, those who have gained the electron already, previously all that atoms, those who were not gaining the electron, they were not stable because there was a shortage of electron. Upon gaining the electron, that all atoms become stable. So atoms very close to the junction on left hand side become stable upon gaining the electron, and atoms very close to the junction on right hand side also become stable upon losing the electron which they were having excess. And here, that is what here it is said, neither having the shortage of electron nor excess of electron. Now therefore there are no charge carriers in depletion layer or region. Therefore there are no charge carrier in depletion layer or region, and it starts behaving as dielectric material. So inside depletion layer or region, there is no charge carrier because all atoms are stable. They don't have neither excess electron nor a shortage. P-type and N-type material act as a parallel plate on both sides of depletion layer. P-type and N-type material act as a parallel plate on both sides of depletion layer, that is dielectric material. On both sides of depletion layer means inside depletion layer now atoms are behaving as dielectric material, that is dielectric material. Therefore, at the junction means at the PN junction, therefore at the PN junction formation of junction capacitor takes place as shown below, and this junction capacitor is very less in picofarad. Pico means 10 raised to minus 12. It is very less in picofarad. Pico means 10 raised to minus 12. All of you know that capacitance of capacitor is measured in farad. Farad is a very big unit. Then microfarad, then nanofarad. Micro means 10 raised to minus 6, nano means 10 raised to minus 9, and then pico. Pico means 10 raised to minus 12. So the junction capacitor is very less. It is in picofarad. And here, this is the internal diagram of PN junction diode. How does the formation of junction capacitor takes place? So this is the formation of junction capacitor inside the PN junction diode. Anode is there, cathode is there, and junction capacitor is nothing but your the dielectric material means depletion layer. Depletion layer behaves as dielectric material because atoms converted into ions, anion and cation. And these two material, p-type and n-type. N-type is large number of free electron. P-type also having only one hole and 7 electrons are still there. Therefore, this is also act as a one plate, metallic plate. This also as another metallic plate across dielectric material, and therefore formation of junction capacitor takes place. And this is the equivalent diagram of that junction capacitor. See, it is in picofarad. Due to net charge on LHS and RHS of PN junction, due to net charge on LHS and RHS of PN junction, that is important, the formation of barrier potential also takes place as shown below. Net charge on LHS and RHS. Net charge means what? Neither this atom is having excess electron nor this atom is having a shortage of electron. So here this is called positive of the battery now, means barrier potential, and this is called negative of the barrier potential because total negative charge of all that atoms is increased. Here the negative charge of atom is decreased, means it is becoming positive charge leading towards the positive charge, and therefore here this therefore there is no charge carrier inside the depletion layer, and p-type material act as a junction capacitor is in picofarad. Due to net charge on LHS and RHS of PN junction, the formation of barrier potential also takes place, and as shown below, the barrier potential also called as knee voltage, KNEE. The barrier potential is also called as knee voltage. Now this is the equivalent of PN junction diode with capacitor, junction capacitor. Now this junction capacitor will replace with barrier potential such that here minus and here plus, and that is again very simple here. So here anode and here cathode. This minus sign is on left hand side and this plus sign is on right hand side. This understanding is very important because why it is on left hand side minus? Because atoms on left hand side, their upon gaining electron, their negative charge is increased, and atoms on the right hand side of the PN junction, upon losing the electron, their negative charge is decreased, means positive charge is increased. So that I have explained you with the help of x-axis diagram, and this is called formation of barrier potential. So here the direction of barrier potentials, here left hand side is minus, right hand side is plus. The direction of barrier potential is always in opposite direction, in opposite direction to the forward bias voltage applied to PN junction diode, to the forward bias voltage applied to the PN junction diode, because forward bias voltage applied to PN junction diode is always anode to the positive of battery and cathode to the negative of battery. That we have studied in say second lecture. Forward bias means anode to the positive of battery and cathode to negative. Therefore inside PN junction diode, the direction of barrier potential is always in opposite direction to the forward bias voltage applied to PN junction diode. Now this barrier potential's magnitude is what? For silicon, barrier potential is equal to 0.7 volt, and for germanium the barrier potential is 0.3 volt. So this is the important fact. Therefore, the silicon PN junction diode starts conducting after 0.7 volt of forward bias voltage applied to it. Therefore, the silicon PN junction diode starts conducting after 0.7 volt of forward bias voltage applied to it, because after 0.7 volt only these electrons will be in a position to migrate from anode to cathode, because this barrier potential opposes, it is in opposite direction to the applied forward voltage. Therefore, this barrier potential opposes to the migration of electron, but if you apply the external voltage greater than this barrier potential, then current starts flowing after zero point 0.7 volt in case of silicon and after zero point 0.7 volt in case of germanium. Therefore, silicon PN junction diode starts conducting after zero point 0.7 volt of forward bias voltage applied to it. It will not conduct for the voltages below zero point 0.7 volt. It will not conduct for the voltages below zero point 0.7 volt, because external voltage is less than internal barrier potential. External voltage is less than internal barrier potential, and therefore electron cannot cross over the barrier potential. Therefore, below zero point 0.7 volt it will not conduct, and it behaves as open switch for all voltages below zero point 0.7 volt. A non-conducting device is behaving as open switch for all voltages below zero point 0.7 volt. Therefore, the measured voltage is always equal to applied voltage till zero point 0.7 volt as shown below. So here, suppose now we have taken anode and cathode and applied the input voltage V in 0.1 volt to 0.7 volt, 0.1 volt to 0.7 volt. And in this way here, inside this there is a barrier potential which is in opposite direction, minus here plus here. Diode is not conducting only, and it is behaving as open switch. Therefore, we have already studied the measurement of voltage when it is behaving open switch. The voltage measured across PN junction diode, which is behaving as open switch, will be equal to applied voltage, and that will, if it is 0.7, 0.1, it is 0.1. If it is 0.2, it is 0.2. Therefore, we have given here 0.1 volt to 0.7 volt, and measured will also be 0.1 volt to 0.7 volt. In above diagram, if voltage applied to PN junction diode Vn is in 0.1 volt, then voltage across diode Vd is also 0.1 volt, and it will continue till 0.7 volt, and it will continue till 0.7 volt. The same diagram is shown now here like this. Applied voltage V in 0.1 volt to 0.7 volt, 0.1 volt to 0.7 volt. Measured voltage across diode will also be 0.1 volt to 0.7 volt, because this diode is not conducting and behaving as an open switch, because applied external voltage is less than internal barrier potential, internal barrier potential is of how much volt? Internal barrier potential is of 0.7 volt. So applied external voltage must be greater than 0.7 volt, then only it will conduct. Otherwise it will not conduct, means it is behaving as open switch. So that we have studied in the second lecture. And now after this, what we'll do here, we'll apply the voltage to the diode 0.1 volt to 0.7 volt only, but we'll connect load resistance here. So when you connect a load resistance over here, as you are aware that key inside barrier potential is 0.7 volt and applied voltage is up to 0.7 volt only. Therefore, diode will not conduct, means current flowing through the diode is zero. Therefore, current flowing in this circuit is also zero. Therefore, current going through RL is 0. I is equal to 0 because diode is not conducting only, and therefore VRL is equal to 0 volt, because VRL is equal to current flowing through RL, IRL or I into RL. Whatever RL, 1 kilo ohm, 2 kilo ohm, 100 ohm, current is 0. Therefore, V is equal to I into R. Therefore, voltage is also 0. And this is very simple. In above diagram, if load resistance RL is connected, in that case, no current flows through RL because diode is not conducting. And in this way, today we'll stop to this, up to this only, because formation of barrier potential you understood, formation of junction capacitor you understood, and formation of depletion layer also you have understood. So this is very important concept inside PN junction diode, and therefore it is said that one PN junction produces one junction capacitor. One PN junction produces one junction capacitor. One PN junction produces one barrier potential. One barrier potential. one PN junction produces one depletion layer. And with this, today we will conclude that you can watch the video again and again and you can clear your concept about the anion, about the cation, about the migration of electron from n-type material to p-type material, about the formation of p-type material and n-type material, which I already studied in the previous lecture. Thank you for watching this video, and in the next lecture we'll proceed after this slide only. Thank you.